My name is Andrew Wilcox from Thermacity Energy, and I think we have some interesting innovations to show you. We set out to answer this question: can we decarbonize the world? Obviously, a fairly lofty goal. So we decided to focus our efforts and resources on large-scale HVAC systems and how we can do that. And again, I think you're going to find some of this fairly interesting from the city's perspective. What we did is kind of went through our thought process of what decarbonization technologies are available to the built environment, and in particular to the retrofit world. New construction has some options available for decarbonizing HVAC systems, but electric boilers, air source heat pumps, great technologies, but can you find enough power in a retrofit application? Do air source heat pumps work during those heating design days in some climates? Maybe yes in Vancouver, in Toronto and Calgary and Atlantic Canada, maybe not. So we set about to implement GeoExchange to the retrofit market and developed our low clearance coil drill rig. We went to the oil and gas world in Texas and borrowed all of this technology to develop this miniaturized coil drill rig to be able to drive down into the parking garages of buildings and retrofit them with GeoExchange or geothermal. And as you can see with our team there standing in front of our prototype drill, it operates well under 7 feet of clear parking garage. And so that's literally the intent, to drive down to the lowest level of a parking garage and drill holes up to about 600 feet deep for GeoExchange. So we have done some of these examples. These are some photographs of an implementation at Cadillac Fairview property 777 Dunsmuir in Vancouver. And as you can see, those green caps in the floor of the garage are the tops of the boreholes. These connect to headers on the ceiling. We leave the garage completely as usable as it was before we started drilling. We haven't used up any parking spots. Those caps can be driven over. We try to locate them in the shadow of columns, but nonetheless, a really successful GeoExchange retrofit in a building. And in fact, Cadillac was attempting to demonstrate their environmental responsibility and get off of, they were a district steam customer in Vancouver and were trying to reduce their steam consumption. So this is great. GeoExchange, wonderful. We can now bring this to the retrofit market. But what are the limitations of GeoExchange? And we have some real experts on our time who have been in the GeoExchange world for about a half a century, Gino, something like that, 47 years, quite a while. But there are some limitations. And in particular, especially in climates like Ontario, one of the big limitations is the necessity to balance these systems. The heat you take out of the building in the summertime to air condition it, you then store in the ground. And then in the fall, you flip the system around and start pulling that heat out of the ground to heat that building through the winter months. What if your loads aren't balanced? And typically what we see, especially in the Toronto area, are heating dominant buildings, and therefore we can satisfy all of that building's cooling needs in the summer, remove all of that heat, but that's the limitation of the amount of heat that we can then pull out of the ground to heat the building in the winter. And quite often we find we need supplemental boilers, gas-fired boilers to top up space heating, but in particular domestic hot water and snow melt loads. So what innovation number 2 is this introduction of what we're calling geostorage. And this is not dissimilar from GeoExchange. It's the same holes in the ground, the same pipes in those holes, the same grout, the same drilling. There's very little different technically, but what we're doing is separating hot and cold thermal storage into separate bore fields. This provides 2 distinct benefits. Number 1, we can intentionally mismatch the size of these bore fields to better meet the needs of that building seasonally. We no longer need to balance heating and cooling loads throughout the year. So we could have a very large hot water or hot storage battery and a smaller cold storage. In fact, we could do hot or cold only storage. So we've come across some examples. Data centers, very little need for heat, lots of cooling. Refrigerated warehousing, same thing, that kind of thing. Lots of heating only residential buildings scattered across the city. We worked on a neat example of a food processing facility with Simcoe Refrigeration. We heard from Amal this morning, where this building was producing food products for 2 8-hour shifts in the day and then generating a lot of heat from that process, and then an 8-hour cleaning shift that needed even more hot water. So we could store the heat from those production shifts on a daily basis and turn around to produce that hot water for the cleaning process overnight. So interesting, any mix of heating or cooling we can do. And the other benefit is being able to store temperatures very densely, right in the middle of that hot bore field. Our goal is to be able to store heat at a temperature that the building needs to use it. So in a retrofit application, you may not need to look at glazing changes, at cladding changes, at expensive HVAC upgrades to accommodate the typical temperatures of heat pumps. So high-grade hot and cold storage separated underneath the building, so still applicable to the retrofit market. How does this benefit the buildings? Well, this potentially, thermal storage in any form, or I should say energy storage in any form, electric or thermal, inherently decouples the hours of the year when energy needs to be produced, when you need to run mechanical equipment to produce that heating and cooling, from the hours of the year when the building needs it on those design days. So we no longer need to run that mechanical equipment during the peak hours of the year. Meaning we probably don't need electrical service upgrades. We can run heat pumps on nice hot summer evenings to generate heat stored in the ground seasonally to then pull out and use during the winter. Same thing, we leverage cold ambient conditions in the winter to store cold in that cold bore field to then store that for use the following summer. So not needing electrical service upgrades, we now get into some of the, and Electra and Toronto Hydro, I think this might be particularly important. It is probably used as a global adjustment mitigation method in Ontario anyway. We're shifting the production of that energy either off peak, meaning nighttime, or evenings and weekends, or whatever times of the year best meet that building owner's needs. So we can now design charging algorithms to leverage the lowest cost hours of the year to run electric equipment to produce hot and cold, or the lowest carbon intensity hours of the year, whatever the building's goals really are. So reducing HVAC demand, or in fact potentially eliminating HVAC demand during those peak daytime hours of the year is probably of significant benefit. And we created this chart. This is the last slide, but if a building is willing and able to electrify their building, that peak on the yellow peak on the left-hand side, if you install an electric boiler to heat your building at only 100% efficient, you probably can't get enough grid capacity to actually implement that technology. Air source heat pumps, great idea, about twice the efficiency, maybe 3 times, something like that. But with half of the demand, maybe you can get enough power, but I'm not sure that equipment will really work during those peak winter days of the year. Ground source heat pumps, terrific idea, probably a halving again or doubling of efficiency, halving of electrical demand needs. So far, GeoExchange hasn't been available to the retrofit market. We can offer this now, that's not a problem. But the blue peak that drops below that line, and I'm showing that on the right side of that dashed line, we can now create a grid-friendly building because at those peaks, we can eliminate the 40 to 50% of that building's electrical demand that is typically used for HVAC needs. So that can now disappear, creating a tremendously grid-friendly building. Thank you.